driven by the 8051. But we have a limitation, right? That we can only go up to 82 degrees because of the math.
Well, the limitation in the math, because in the ADC, in order to read the millivolts out of the LM35, it won't read 0 to 5 volts, so I had to split the voltage, and then so the math is for 0 to 5, not for millivolts.
Go ahead and touch it. I think, yeah, let's see it go up. Oh, I think I got it. There it goes. Oh, up 71. 77. Obviously it's working.
You don't want to go to 82, it's going to go over.
I mean, 82 is it's going back down now. This one's going to be particularly hard.
And also, this is the LM35, and so it's actually written in Celsius, so inside the program I had to change it to Fahrenheit inside the control of this.
Well, I added a resistor earlier and then I made it brighter, but I put the resistor on. I think it was like a 1K.
A 1K? Where does 1K go?
I think it was where that A was.
Where? Can you point to it? Let me see. For the future?
To that one.
Oh, okay. Oh, okay. So, all right. So here, let me see if I can change this. So it's like a message, and so yours is also scrolling.
Yeah, like you can write whatever you want, and then the message will just scroll left and right.
Okay. Oh, but it's going both ways.
Yeah.
Left, right to left. Oh, wow. Okay. So once again, we have to do this next semester because that's a traffic light problem, but that you improve, right? Because the other one was very confusing. So this is like two streets opposite of each other?
Yes. No, they're just opposite, but they're like a 4 intersection.
Okay. And then, so if you push the reset button, does it start from the beginning?
Yes. Sure.
Okay. Go start from the beginning, see what it does. Okay, so they're all off. Oh, and then they start. Okay.
Yeah.
All right. I plan to do this one as a must, as a kind of a beginning. After I do this fundamental Arduinos, and based on your code, hopefully I'll be able to get right through it rather than where the mess we started with.
Well, it's very simple from what it was already.
Yeah. You want to improve keypad driving a 7-segment display with the 8051. So each time you press a key, okay, one, okay, good. So the whole logic of I made you guys work on this to get it on one board. Before it was on a whole bunch, right?
Yeah, it was on 3 boards previously.
And the code was kind of iffy, and we kind of fixed it up.
Okay, good.
So we simplified it, put it on, so there's minimal wiring. We just had these to work with, but we could have run just wires across to make it a little bit cleaner.
Yeah, this is hard enough though. Okay, good. By the way, so I got to make sure the buttons here. This time you simply took the keypad number and then go to the 7.
Yeah.
Right. Okay. Go ahead and enter a few.
So each and every push will show up on the display from 1 to 9. This is only one segment.
Okay. Good. All right. What happens to those symbols like the star and the pound sign? Does it do anything?
No, they don't do anything.
Okay.
I wasn't able to program those.
All right. Still, that's good.
So we have to use the 4511 IC.
Yeah.
So the whole right side is for the inputs for the keyboard, and on the left side is for the inputs on the Arduino.
Okay. So what does this 4511 do?
It's a decoder for the segment. So this is a cathode.
Okay. The 7-segment decoder driver.
Yeah.
But common.
It's literally just a series of consecutive LEDs, all single color. And the board is just consistently playing a single tune. I think in this case it's Twinkle Twinkle Little Star or something like that.
Okay.
So turning up the crim pot there, you'll hear it's currently running, and it's a little bit touchy at the lower end, but as you turn it up,
okay,
it lights up. You can get it lower, but again, it's really touchy. And as you turn it up more,
okay, yeah.
You can hear it going. For whatever reason, that LED is working, but I haven't been able to get it to like quote unquote max volume.
Okay. You obviously improve the wiring because I have to hand it out to the class, and so hopefully, in your opinion, the whole class 386 can do this, right?
Yeah.
Okay, so go ahead then.
2, 3, A, 4, 5, 6, B, 7, 8, 9, C, R, 0, pound, D.
All right. So you got all the hexadecimals?
Yeah.
Okay. I don't remember them doing the hexadecimal. That's fantastic.
Well, it doesn't have E and F.
E and F, no?
Oh, yeah.
No, you're missing is E and F.
Oh, okay.
Oh, it goes to 2. Oh, it's 4 by 4.
Oh.
It was 6 by 6.
Okay, so not a real true hex. Keep it. Okay, well, that's fine. No, I just want to just do anything to drive it into the 6011. Look at that. So anyway, just make sure I get the code for all this, okay?
Yeah. It's in the report.
It's in the report, okay. Very good. I know, it's not easy. But I like the way you got it nice and clean on one little board. Remember how they did it in 3 or 4? Very good. Very, very good. Is that my keypad or yours?
Your keypad.
Mine? Oh. So you put those cables on it?
Yeah.
Okay.
Those are Daniel's cables.
Oh, yeah.
Keep them.
Oh, okay. Those are the ones you told me about.
Yeah.
All right. Oh, I see what you did. Oh, okay. Let me get a real close up. Oh, okay. You put the keypad over here on the board and then the cables in the same row. And we say we're going to test batteries if they're good. And so green is good, right?
Yeah.
And so, but if it's too low, then red. Okay, so that's a bad one.
Yeah.
But the problem is yellow, which we're supposed to be sort of good.
Yeah. Well, we can't find a battery that has.
Right in that middle value, okay?
Basically.
All right. So